Loudness and loudness level. I will talk about loudness level definition, zone phone relation, power law, temporal integration, equal loudness level contours, hearing thresholds, requirement, measurement methods, and maybe loudness exercise. We have a hearing threshold where it means that the necessary impact in dB to hear anything. This is a hearing threshold curve here, minimum at about 3400 Hertz because of resonant frequency. Yeah, and we have yeah, and it is increasing. Yeah, after the minimum in about 10,000 or less than 100 Hertz and so on. You can see it here. So yes, and we have some. It's for normal people, hearing people. We have also a pain threshold, uncomfortable threshold for normal listeners. Yes. Yeah. Psychophysics. Physical stimuli gives a perceptual experience. Or the intensity of loud is to give a perception of loudness. What is loudness? Definition: loudness describes the subjective perception of the strength of a sound. The subjective perception of the strength of the sound, how you perceive it. It measured in zones or son. A tone with loudness of 8 sounds is twice as loud as one with 4 sounds. So there's a proportionality. It's a perceptual and not physical intensity, SPL. Loudness versus intensity. Yes, intensity is an objective measure. dB, decibels, SPL, sound pressure level, A and C, listening and so on. Sound level meter can measure it. And loudness is a subjective measure. How loud are these decibels for you? And always an indirect measure, often defined as perceptual strength. Different ways to measure, for instance, categories or numbers. Categories could be uncomfortable loud, okay loud, soft, very soft, and so on. Loudness rating method. There's assigned an arbitrary loudness value, for instance, 100. The probe listener, the listener responds on response with number corresponding to the perception of the relative loudness. For instance, 50 is half of the reference, 200 is the double. Okay, I'm just, yes. Okay, and we can have a talk about loudness experiments. 20 presentations, probe level is varied, reference fixed at constant level. And your task is to evaluate the loudness of the probe relative to the reference. Write a number corresponding to the relative loudness you perceive. That could be a way. And we have a log 2 rating. It's so that it's a difference between when there's a 10, I will say like this: if the 10 dB increase in sound pressure level, then there will be on a log 2 axis a 1 increase. Yes. So it will. That means that will 10 dB increase in SPL means a double in loudness. Loudness, yes, loudness grows measures. You have a magnitude estimation. Give a number that corresponds to a loudness of any sound, but any number can be used, and no numerical examples given. And then there is a categorical. It's okay, but loud, but okay, comfortable, and so on. There are some strengths and limitations. For instance, for categorical strengths, meaningful labels appreciated by and useful for clinicians is soft, very soft, and so on. And the limitations, discrete data, how to analyze strengths. Task is seen as simple and easy to understand for all types of patients and participants, which are limitations. Steps equally big and strengths same range of data for all participants. Scale has the limitations. Scale has boundaries, floor and ceiling effects, and many different labels used, language culturally dependent. So that is how it's a good, it's nice definitions. Clients understand it, but how to analyze the discrete data. Are the steps equally big? Absolute magnitude estimation. I can start with strengths. This classical method, often seen as most direct and effective method, scales has no upper boundary. Scale is continuous. And then the limitations. Some explanations needed for participants. You can use any number. Sometimes it's 7, sometimes it's 12 for the same situation. Every participant has own rating range. Transformation of data needed for analysis and comparison across participants. Yes. So there are a lot of stuff here. How do the numbers mean in terms of loudness? How should clinicians use this? Loudness level is loudness is a perceptual unit in zones that comes from perceptual experiment. How can we relate perception of intensity to the physical intensity, as a perception versus physical? So first axis physical scale in hertz or dB, SPL, and the second axis perceptual scale. Definition: sound pressure level SPL of 1000 hertz tone that sounds equally loud. Can be measured using a paradigm units. And that means, so if you have that means, if you have a sound at 1 kilohertz and the SPL is 40 dBs, 40 dBs, then it means that there's 40 some phones also at that time. But remark that the level is changing. If you follow a curve, it's called equally loudness level curve. If you follow a curve which is 40 dBs at 1000 hertz, it could be, for instance, 30 dBs at 70 hertz, or maybe 10 dBs at 10,000 hertz. No, I'm just, it can vary. It's a little bit sloppy here. It varies. So 40 dBs at 1000 hertz, it could be, if you follow this contour, equally contour curve, it's called equally loudness level contours. If You go to 2000 Hertz, it could be another number of decibels, but it's still the 40 dBs level contour curve. So the loudness uh, depends on the frequencies. Okay, it could be better explained. Loudness level continued. Frontally incoming sound, called frontal incidence, signals are poor tones, one frequency at a time. It's binaural. You are listening with two ears. Binaural listening. No reflections. You have an anechoic room. No background noise. That would say an anechoic room. Subjects between 18 and 25 years. So we get this equally loudness curve. It's better now. You go to 1,000 hertz and you find a curve with 40 phones. That means the sound level pressure is 40 phones. If you follow this 40 phones curves at other frequencies, it could be 40 phones at 200 frequencies will give a sound pressure level more than 50 hertz. So it's a contour. But remember, it's easy to say. At 1000 hertz, the phone numbers, the number of the phones and the numbers SPL are the same. 40 phones at 1000 hertz means 40 dBs SPL. Yes, follow. Yeah, it's those equal contours, equal loudness curves they are following the absolute threshold curves. You can say this is just a transformation or what's called parallelforskydning. Yes. A and C weighting. A weighting is, you can call it a reversed 40 phone cone curve. A and C, we have C. C are weighting the all frequency almost equal. The A curve is weighting the low frequencies less than higher frequency, or a frequency area between, for instance, 1,000 and 4,000 or 5,000. And from fundamentals, page 23, about the difference between A and C weighting. On the other hand, the A weight sound pressure level is the most widely used single value measure of sound, because the A-weighted sound pressure level correlates in general much better with the subjective effect of noise than measurements of the sound pressure level with a flat frequency response. C-weighting, which is essentially flat in the audible frequency range, is sometimes used in combination with A-weighting, because a large difference between the A-weighted level and the C-weighted level is a clear indication of a prominent content of low frequency noise. Okay, the result of measurements of the A and C weighted sound pressure levels are denoted L index A or L index C respectively, and in unit is dB decibel. If no weighting is applied, the level is sometimes denoted L index Z. Okay, so I will stop here and continue with loudness level.